Technical sketching is a skill crucial to the success of any engineer. It's a very useful communication tool that can be used regardless of what language you speak or what type of engineering you're in. So let's look at some of the basics about technical sketching. First of all, I want to talk about why the heck we need technical sketching. So we have this piece here, and the first thing I want you to do is pause this video and try writing out a description of this part using only words. Now that you've tried that, do you think that's an effective way to tell someone how to build this part? In other words, could you take those words that you just wrote, give them to a manufacturer, and expect to see the exact same part returned back to you? Why do you think so? It's likely you think that that's not an effective way, because perhaps it's difficult to get enough detail in using just words. And that points to why we need something like technical sketching. With technical sketching, three-dimensional sketches are used to convey the general shape of the object that you have in mind, and two-dimensional sketches give details that a machinist may need to build the object. Some of those details may include the dimensions, but also what the part is made out of, what kind of texture it may have, or some things like tolerances. So in other words, how much bigger or smaller than the ideal dimension can your object be? We'll learn details about all of those things, and we'll learn about some specific types of three-dimensional and two-dimensional sketches. For starters here, we have 4 different types of technical sketches. The multi-view is our only two-dimensional sketch that we'll study, and it shows one side of an object on each view. Pictorials, which are our three-dimensional ones, show 3 sides of an object in just one view. And you'll see that there's 3 different types of pictorials: isometric, oblique, and perspective. Isometric is the most common. I apologize. Isometric is the most common pictorial that we use, and a specific type of isometric is called isometric. We'll talk more about that in a moment. That's the one that we're going to focus on, but we also have 2 other types, such as oblique and perspective. Architects most commonly use perspective drawings, and perspective drawings are ones in which the top view is minimized. Think about it. If you're an architect, typically we don't care so much about how the top of a building looks, but we do care about the sides. An oblique drawing, on the other hand, really focuses a lot on one particular side of your drawing, and both the top and the other side are minimized. An example of someone who might use an oblique would be someone who's making cabinets. They really don't care about what the sides and the top look like. They care a lot about the front of the cabinet. Again, the one that we're really going to focus on is an example of isometric called isometric. We know that that term iso means the same, and so in an isometric sketch, all planes are equally shortened or tilted, and all the major axes, the x, y, and z axes, are 120 degrees apart. All isometric sketches start with some sort of a cube, or maybe not exactly a cube, but a rectangular prism, depending on our dimensions. And it's that cube or rectangular prism that defines our axes. Here's what I mean by that. When we're doing an isometric drawing, we're going to determine the height, width, and depth of our object, and then we're going to lightly sketch a box with those 3 dimensions. Once we lightly sketch that box, our drawing of our object will fit within that box. And we'll see an example of that in the next video. Before we can actually jump right into sketching, though, we need to know how to use this isometric grid paper. Because our isometric has kind of skewed sides there, we don't use typical grid paper. That's called rectilinear grid paper, by the way, where all of our grids are squares. Instead, we use this isometric grid paper where our grids are triangles. And you'll see that there is a correct orientation and an incorrect orientation. And hopefully just from looking at this, you can see the difference. For some of you, you may focus on the lines in between those rectangles, and you'd see that the lines with the correct orientation are vertical, whereas with the incorrect orientation, they're horizontal. Or perhaps you focus on the triangles in here, and you notice that with the correct orientation, the triangles point left and right, versus the incorrect orientation, they point up and down. So when you're starting an isometric drawing, make sure that you have your paper in the correct orientation. See the next video for an example of exactly how to do an isometric drawing.